Good afternoon, everyone. Welcome back to the online sessions on MCC subject. So, in today's class, we'll continue with our discussion of the various parameters that we normally going to use in the trunket system and quality of service. Okay, so in the trunket system and the quality of service, before we just discuss, let us have a recap of the concepts or a architecture of the or a structure of the, not architecture, basically I can call it as structural architecture, because it is going to be architecture means it should contain the transmitter and reception part. But here this section has been shown with the architecture up to PSTN, so we can call it as architecture of the mobile radio system or cellular mobile system, because it involves the MSC and PSTN. If you draw the uh, if you draw the mobile system without MSC and PSTN, it is known as structure of the mobile cellular system. Whereas this is nothing but the architecture of the mobile radio system or architecture of the cellular system, basically. Okay. Now, in the previous classes, what we discussed, we have just discussed about that we normally going to have hexagonal cell. Now, at the center of the hexagon, we normally going to have the base stations. So all these antenna, all these towers, what you're seeing is known as the base station and base stations, or something like base station antennas. And from these base station antennas, the mobile units are normally going to receive the signals. So the mobile unit has been shown by a car or a moving vehicle, because the mobile is normally going to move from one place to another place. Therefore, we have shown it by using the we have shown it by using the car or any moving vehicle, in fact. So this car is going to resemble us a mobile unit. Mobile unit is nothing but an element which is normally going to move from one place to another place. It is a movable element. That is called a mobile unit. Okay, so now these cars are simply known as the mobile units, whereas these towers are known as the base stations. So mobile unit can be called as a mobile station, mobile user, or mobile unit. So anyone we can simply call this particular mobile user. Okay. So therefore, and these towers are known as the base stations, which provide access between the mobile users. Now, what the base station is actually doing, the base stations are provide access between the mobile users and the mobile switching center. This MSC is known as mobile switching center. This base station is providing access between the mobile user, the car is there here, between the mobile user and the MSC, between mobile user and MSC. Who is providing the interface? This base station is providing the interface between these two. That means this mobile unit is normally going to communicate to MSC via the base station. So mobile unit is going to give information, is normally going to send signal to the base station. Base station is normally going to in turn send the same signal to the MSC. Then this MSC is going to send the signal to the PSTN. This PSTN is further going to send the signal to the nearest MSC, and that MSC is once again given a signal to such a base station. Okay, that means this base station, some of the base station located in the area of the cellular system at the destination side. So this entire part has been shown in the source part. Destination but also we can have the same kind of thing, or otherwise say this mobile unit want to communicate with this mobile unit. In that case also, these two mobiles are normally coming in the same zonal area, say Telangana area, so same area, Andhra Pradesh area, same area they are simply coming into, the same area they are simply coming into. Therefore, the same existing mobile structure is normally been used to communicate. That means, say this base station A is normal, this particular mobile unit want to communicate with this particular, this black car and this black car. These two guys want to communicate with with each other. So this mobile unit, imagine that it is revolving only in this hexagon area. This mobile unit is revolving only in this hexagon area. So in that case, what is that which is going to happen now? Let us see. This mobile unit, which is in the left top corner, want to communicate to this mobile unit in the bottom side. So this mobile unit is going to send a request to the base station. This base station will in turn send a request to the MSC. Then this MSC is normally going to connect to the nearest base station of this particular mobile. to establish the call. Now this mobile unit is going to send a request to this mobile unit that is getting a call. Now once he says okay, then a call is been established between these two mobile units using the corresponding base stations. That means when these two are normally going to make the conversations, how the call is simply proceeding further. So here what happens? The call is been established between these two mobile units via the base station, the base stations, the local units and the common MSC. That means the voice signals which is been communicating here. How they are communicating? The mobile unit to the base station A, local base station A to the MSC, to the MSC to the base station A, then mobile unit. When this fellow is going to call, this mobile unit is going to speak something. This information is once again goes to the local base station unit. From base station, once again it comes to the MSC. From MSC it comes to the base station. From this base station, once again the call goes to this particular user. So like that, the channel is normally going to get established between these two people via base station and the via local base stations and the MSCs, right? Now in this process, for example, if this mobile unit is moving from this base station area to another base station area, what is that which is going to happen now? Handoff process is normally going to take place. Handoff process is going to take place. By virtue of handoff process, what happens? This mobile unit will not experience any disruption in the call. He just feels that the call is there continuously. Okay, so like that, we normally going to have the call between these two particular people. Okay, so after this, what is that we normally have got now? We have seen. See, in the previous class, we have dealt about this now. Now, see this A, B, C, D, E, F, G and A, B, C, D, E, F, G, A, B, C, D, E, F, G. This is a set of cells used in a particular area. Now, same set of cells are simply been repeated here. Now we may have 3, 5, 7 or any number here based on the capacity of the channel or capacity of the system. So here 3 has been taken. Now all these 3 put together is known as a cluster. So in a cluster, what is that we are going to have? We are going to have same set of frequency bands has been simply repeatedly used. That means frequency reuse has been repeatedly used for all these different set of cells. So put together all these things is simply known as a cluster or group of cells. So all this is known as a group of cells. In a particular group, we normally going to use this kind of a B, C, D, E, F, G. Now another group, when you think about, say for example, another cluster, you can repeat the same set of the frequency channels. So what is frequency reuse that we discussed? See here, this group of cells are having A, B, C, D, E, F, G. Again, this group of cell is also having A, B, C, D, E, F, G. Means what? This group and this group are normally using the same set of frequency channels. So same is the case with this group also. But even though they are transmitting the signal simultaneously, but these signals are not going to get interfere, even though there is a frequency reuse due to the distance problem. So as the signal is getting transmitted to longer distances, more than based on the design constraints, say more than 5 kilometers, the signal is simply going to get deteriorate. So thereby there is no question of interference between the two neighboring cells. Now this A and this A is known as neighboring cell. This B and this B is known as neighboring cell. Okay, so these cells won't get simply involved in the interference, will not get interfered. Okay, so this is what we have seen in the last class. We have seen this in the last class. Then next one is going to be this one. That means what? If we feel that there is a huge amount of congestion, there is a large amount of congestion taking place, then what we can do is we can just subdivide the given cell into some other cells. Now these cells can be further subdivided into some other cells. It is known as a cell splitting concept basically, which we normally going to discuss now. Okay, so the overall cell, the bigger area, the first cell which is there in the cellular communication is nothing but umbrella cell. So all the cells which are there inside this particular bigger cell is going to be known as micro cells. Micro cells are usually known as small cells for us. Now here we are going to continue with where we are left over in the previous class. In the previous class, we are discussing, we have touched about the trunking system. We have touched about the trunking and grade of service. Trunking and grade of service. What is the concept of trunking basically? Now, whenever you normally think about the concept of trunking, you should get into your mind the process of multiplexing. What is basically multiplexer? Multiplexer is normally used to share a common resource, share a single resource or limited resource to multiple users. That is what the basic application of a multiplexer. Okay. Now, similar kind of thing is normally used in the trunking process. So, trunking is normally used to share relatively small number of cells in a cell. Trunking is normally used to share a small number of channels in a cell. That means we normally going to have limited number of channels in a cell. So using this trunking, what happens is it is normally going to share, this trunking is normally going to share relatively small number of channels in a cell to a large number of users. Now imagine there are so many mobile users, but all these mobile users are normally going to share a limited number of channels in a cell. See, the mobile users can increase, can go on increase. But as the number of mobile users are increasing drastically, go on increasing drastically, we really cannot increase the base stations or cellular towers which we are seeing around us. We really cannot increase. So that is what the scenario we're normally going to get. So every base station is going to have some limited number of channels available with them. So it provides the communication between two mobile units based on the limited number of channels. Say the practical scenario, what is that? The number of users are increasing day by day. Today, the base station has been designed to accommodate 100 mobile users or 100 mobile units or 100 mobile stations. Tomorrow it will increase to 150. What will happen now? The number of users have increased. But what happened now? The number of channels in a cell has become small in comparison with the number of users who are going to use the channels. Now, this is the scenario where we normally incorporate this concept called trunking. So, trunking allows a large number of users to share a relatively small number of channels in a cell by providing access to each user on demand from the pool of the available channels. So that means here once again similar concepts we are going to have, but repeatedly we are going to see only small differences will be there. Now what do you mean by pool of channels? Now no channel is preoccupied by any user. There will be some pool of channels available. So based on the demand of the user for a given channel, so one channel is normally taken from that pool of channels and assigned to the given user. So now that means how the users are normally going to be allocated with channels. Users are allocated are going to get allocated a channel on a per call basis. That means whenever somebody makes a call, that request will first of all go to the base station. Now base station is going to have some pool of channels available with them, and based on the call request, it is normally going to pull the channel available in the pool. Then and when the call is completed, then the channel is once again returned back into the pool of the channels. So that means no channel is preoccupied to any of the user, pre-assigned to any of the user. Therefore, truncated data systems are designed to handle specific capacity, specific grade of service. So they are designed to handle a specific capacity, not a unlimited capacity. To handle a specific capacity at a specific grade of service, we normally going to use this. Now, once this grade of service comes into picture, what is the grade of service? Normally use the grade of service? Grade of service is normally used to know the quality of the service that we are normally providing to the user. So whenever the quality of a service comes into picture, there are so many other parameters related to the quality of service comes into effect. What are all those parameters in the grade of service? So therefore, we can just define the grade of service as a measure of ability of mobile user. This is a mobile user to access truncated system during the basic hour. So during the basic hour, every mobile user want to use the cellular mobile system or cellular mobile architecture. So it's the ability of the mobile user to access the trunket system during the basic hour. So how fast or how better, to what extent he is normally going to use the cellular base station. That ability of using the mobile cellular architecture or mobile networking during the basic hour is known as simply grade of service. Now, in order to find out how better the system is working, we normally go for the grade of service kind of a parameters. So here, what are the parameters? Parameters are going to be once again very much straightforward. That are going to be, there are so many parameters which are normally involved in figuring out the grade of the service, in which grade the system is really working. Grade 1, grade 2, grade 3 kind of a services. So grade 1 is normally going to be provide maximum service, maximum satisfactory service to the user. Grade 2 is going to be little bit less uh, prioritized service. Similarly, grade 3 somewhat less than grade 2, like that. So we're going to have various grades of service based on the service options we provide to the customers or subscribers. Okay, so the first one is going to be setup time. So what is setup time here? So very quite common here. The time required to allocate radio channel to a requesting user is known as setup time. That means once a request has been made by the mobile user, the base station has to set up the call between the two mobile users. Now the time taken to establish the call, okay, is simply known as a setup time. So the time taken to establish the call between two mobile units is known as the setup time. So we have seen in the just previous slides that what are all the elements involved, or what are all the components involved in the process of allocating a call between two mobile users. What are they? They are going to be base station of the local mobile unit, then MSC, from MSC once again base station of the local mobile unit, then the mobile unit. Okay, so these two has to compare, all this process has to continuously continue throughout the end of the call. That is what we normally going to have. So in this, one drawback we are seeing, as we explained earlier. What is the drawback that we can really see here? The drawback is that even though the two mobile units are adjacent to each other, the call should go by all this process. So it is normally going to take a lot of time. So in this process, if the channel is not available, simply it says that simply says that the call cannot be reached now. So that's how the one of the drawback that we can normally encounter in the case of this kind of a simple direct setup mechanism. So anyway, it is the time required to allocate radio channel to a requesting user. What do you mean by radio channel? It is also be frequency channel. We normally going to assign certain range of frequencies to communicate signals between the two mobile units, two mobile users. The next one is next rated value is going to be, next rating is normally performed for grade of service is going to be blocked calls. Now we all know what is call blocking. So call which cannot be completed at a time of request, then that call is normally going to get dropped. Okay, so therefore that call is known as a blocked call. So if the network is busy, so after certain time of request period, then still if the call could not be established, then the call is simply going to get blocked by the base station. So that is nothing but a block call. So the block call is nothing but a call which cannot be completed at a given time of request due to congestion, also referred to as the lost call. That call is normally going to get lost altogether. So next one is holding time. Holding time is nothing but average duration of the typical call time. So in a particular base station, imagine there are 100 users. Now the average typical call time, the typical call duration time of the user will be calculated. That time is known as the holding time. So among these 100 people, what will happen? Some guys will be talking in 5 minutes, some other will be talking in 10 minutes, some other will be talking in half an hour. So all these are calculated and this average has been taken. So that average is nothing but the holding time. So average duration of the typical call per user will be taken something like that. So it is denoted by the letter H. Okay, normally it is a time, it is basically a time related kind of a thing. Therefore it is represented in seconds. So it is channel used for a certain duration of time while we talk. So that means that is what the holding time we normally going to have. The next one is going to be the request rate. What is the request rate? The average number of call requests per unit time. So whenever a mobile unit want to make a call, then what he will do? He is normally going to make request to the base station. So it is an average number of call requests per unit time is known as simply known as a request rate. At what rate on an average every mobile unit is normally going to make request to the base station. That is what called average number of call requests per unit time is known as a request rate, which is denoted by say lambda here. So it is measured in terms of number of calls per hour, 1 hour. So next one is traffic intensity. What is traffic intensity? Measure of channel utilization time is known as traffic intensity. Measured in erlongs, it is basically measured in erlongs. So measure of channel utilization time. So here everything is related to the time. Okay, based on the, because everybody want to have their call under time bounds. So today let us suppose I made a call now at 4:05. Okay, then I expect a call to be connected after 1 hour. I don't want that. I want the call to be connected immediately. So therefore, all this grading of service grades can normally made based on the time dependent parameters only. So therefore, one more parameter is going to be there like traffic intensity. It is normally known as measure of the channel utilization time. Total channel utilization time, how much time you are utilizing the channel. It is basically measured in a long denoted by A. So next one is load. Traffic intensity across entire radio system measured in a long is known as a load. That means there is a load on the system. Load on the system means what? At a particular duration of time, say you want to find out the load on the system. That means how many users are simply connected to the radio system. I just wanted to know. Therefore, that particular thing I simply call it as a load. So it's known as a traffic intensity across the entire radio system is known as a load on the system. Next is erlong is basically unit. A channel kept busy for 1 hour is defined as having a load of 1 erlong. So if a channel is kept for 1 hour busy, then it is nothing but having a load of 1 hour represented in erlong. So let the average number of mobile users requesting service be lambda. So in the overall cell, let us suppose the average number of mobile stations requesting the service for the base station is going to be say lambda. Then the average time for which mobile stations requires service is hold time. That means average time that the mobile users are engaged in the call is nothing but h. Then thereby I can just find out the traffic intensity. Traffic intensity becomes equal to simply lambda into h. H is the time that is known as holding time. Average time that the users are talking in the network, and lambda is nothing but what? Simply number of rate of requests made to the base station is nothing but the lambda for us. So therefore that decides about the traffic intensity of the mobile system. Then further, let us extend our discussion further to get into some other parameters. So let us say for a system containing U users, there are U number of users. The total offered traffic intensity is A. So the A is equal to U into AU. So this is going to be AU. So total traffic offered is going to be something like total number of users are U presently under consideration. Then it is going to be simply U into lambda H. That is the formula we're going to have. If there are C channels, then the traffic intensity per channel. If there are C channels in the system, per channel, what is the traffic intensity? It is going to be UAU by C. So this is what we normally going to have as a formula to perform some little problems on this. So let us look into a problem now. A simple problem now. In a cell with 100 mobile stations, that means there are 100 mobile units in a particular cell. What do you mean by a cell? Cell is not a mobile phone, cellular mobile phone. Cell is nothing but a total area of coverage of a base station is known as a cell. So in a cell with 100 mobile stations, on an average, 30 requests are generated. 30 requests are generated during 1 hour. 1 hour means that 3600 seconds is known as 1 hour. With average holding time t is equal to 360 seconds. That means in every 1 hour 30 requests are being made to the mobile, sorry, to the base station. 30 requests have been made in 1 hour to the base station. By how many? By 100 mobile stations. In how much time? Obviously in 1 hour time. So the next is, once if they get connected, once if they get connected, how much average time they are talking in the in the mobile unit, in the mobile network? For 1 hour they are talking. That is what the average uh, you know holding time we can have. Then what is the request rate we can have? Request it is always calculated with respect to the hour. So therefore 30 requests are being made with respect to hour, means 36 seconds. So therefore the request rate is going to be 30 by 3600 requests per second. Now offered load, what is the load offered for this now? The load offered for this is going to be simply A is equal to lambda h. Therefore lambda is nothing but 30 by, same thing, 30 calls by 30 calls have been requested in 3600 seconds into h. What is h? It is the holding time per call. 360 seconds have been utilized for a single call, per call. So this is what we can have now. So therefore by calculating this, what we can get now, this 360 will go, this 10 and 10, 1 will go, 3 is remained. So we normally going to get 3 longs here. So this is what the basic formula, basic problem which we can have. We can find out to find out the some of the performance metrics or grade of service parameters of the cellular mobile system. Okay. The next concept is going to be very important concept that what we are talking about. What is the problem we have in the real time? The problem we'll be having in the real time is that the mobile stations cannot be increased. The mobile stations cannot be go on increased. Whereas the the base stations cannot go on increase in the real time. Whereas the mobile stations will be going on increasing day by day. So nowadays every user, that means every human being is having 3 to 4 mobiles. 3 to 4 sims he is having. That means 3 to 4 mobile units are there. He is handling 3 to 4 mobile units. So day by day this count is increasing. But day by day the base station count cannot be increased to that extent. So therefore the problem comes here. That means providing the service to this many mobile users is going to be a challenging task for the design engineer. Now to overcome all these problems, we have to figure out certain techniques. So those techniques we are normally going to discuss now. They are known as cellular design techniques, are needed to provide more number of channels to the mobile users. So as the demand for service increases, what is the demand for service increasing means what? The number of mobile users are increasing, or mobile stations are increasing, means what? All these people are expecting service from the base station. So system designers have to provide more channels per unit coverage area. That means the coverage area is same. We cannot change the coverage area. Say if you design it for a cell for 5 kilometers area, we cannot really change that. That is what the problem which we normally going to encounter. Well, so now in order to provide more number of channels to the mobile users, cellular design techniques have been framed. Those techniques are 4 basically that we have in the syllabus. One is going to be known as cell splitting. Second one is going to be sectoring and micro cell zone, and next one is going to be called as repeaters for us. What is nothing but cells? There are 4 important techniques: cell splitting, sectoring, microcell, and repeaters. Okay. So this is a very important concept. This question has come many times in the examination. They are asking it as a short answer question for 6 marks. In the bits usually, are long answer question. And if it is a long answer question, then you should write all these 4 techniques in elaborate. Okay. Now what is cell splitting now? Cell splitting increases number of base stations and allows orderly growth of the cellular system. So cell splitting means what? In order to provide utilization to more number of users, the only option is that you normally going to have more number of cells. Now already the area you cannot decrease. Therefore, we normally going to split the given cell into n number of cells, just like umbrella cell. Under umbrella cell, you normally going to have many other subcells. So that means the cell splitting is normally a process which you normally incorporate to increase the services to the users. So cell splitting increases number of base stations obviously and allows orderly growth of the cellular system. So growth of cellular system is what? Providing more number of services to the users. More number of services to more number of users, mobile users. Next concept is going to be sectoring. So sectoring uses directional antennas to further control interference and frequency reuse. Now the problem here is that as you go on increase the number of base stations, the problem of interference is also going to slowly increase. To avoid the problem of interference, what we do is we can just further go with a directional antennas. So directional antennas are normally going to radiate its EM waves only in a particular direction. So one way is to control interference when you increase the number of cells is by using the directional antennas to control the interference and frequency reuse. So this is simply known as sectoring. So by the process of sectoring, we achieve this particular process. The next one is microcell. Microcell. So microcell zoning distributes coverage of cell and extends cell boundary to hard to reach places. Now these microcells are normally preferred at certain areas, even though you have a cell zone, say there is a BSNL network, say there is Airtel network, in those places we really cannot, at some places we may not get the signal. So in that case, what we do, we just simply go and place another small base station, which is normally going to cover in the area where we are not getting the signals properly. So that cell is simply called as a micro cell. So micro cell is once again part of the major cell, which is called umbrella cell. Okay. So now let us look into the cell splitting concept now. What is that cell splitting concept altogether? See, this is what we are talking about now. Cell splitting means what? If the radius of this cell is equal to r, we normally going to have various cells, subcells with radius r by 2, which are connected with respect to this particular cell, nearer to this cell. So here r by 2 cell, r by 2 cell, r by 2 cell. Still you wanted to have one more subcell in this. There are some regions where at some of the points we cannot really reach the signal. Then in that case, what we can have? We can have further subcells in this where the radius of them are normally going to be r by 4 and one more cell r by 4. You can just see the small cells here, r by 4 radius, which is very very small now. So like that, further we can just simply decompose, we just simply further penetrate into the more number of the subcells. Okay, until we really provide service to many number of the subscribers. Okay, more the subscribers, more is going to be the revenue generated for the service providers. Therefore, that is the reason why the subscribers services has to be increased. So this is one of the mechanism or a method called a cell splitting, using which we normally going to provide services to many users. So this cell splitting reduces the call blocking probability in a particular area. Certain areas signal may not go. So in that area, we normally incorporate these particular small cells. So it also increases the frequency with which mobiles hand off from cell to cell. So mobile handoffs has to increase here or will be increasing because cells are becoming very much nearer here. So this particular concept is simply known as the cell splitting concept. So using cell splitting concept, what we do, we just simply construct many number of cells with the criteria of reducing the radius by half with reference to the basic cell under consideration. So this is what known as the cell splitting concept. In the next class, we deal with the other parameters, to other techniques to improve the service provided to the subscribers, like sectoring, other concepts like sectoring and all these concepts. Okay, so for today, thank you very much for today. Thank you so much.